Hello, lovely students of mine. Welcome to the online lesson for 5.4, Adding and Subtracting Polynomials. First, we need to define what a monomial is. So a monomial is a real number, a variable, or a product of both with whole number, which just means positive integers plus 0 exponents. So the whole number or the exponents need to be whole numbers, positive and including 0 as well. A polynomial, so here's now we're down to a polynomial, is a monomial or a sum of a finite number of monomials. So we're first going to look at an example that involves just looking for monomials and being able to identify them and also finding their degree. So to determine if the following expressions are monomials, and if so, then you find the degree. This first one is a monomial. Note that a to the second, this is a positive number, it's an integer. This one is 2b to the second and c to the second. It's a combination of, it's a product of real numbers, which is 9, and variables, okay? But since all of their integers, or all of their exponents are integers, it's a monomial. So we can say, yes, it's a monomial. Now the degree is basically the sum of, so to find the degree of a monomial, it's basically the sum of all the exponents in it. Okay, so the degree in this case is 2 plus 2 plus 2, because of those, which is equal to 6. Okay, next, part B, it looks as though because of this 9 down here that this would not satisfy the definition of what a monomial is. But keep in mind that a real number, this 1/9 essentially, if you want to rewrite this as 1 over 9 times a squared b to the second c to the second is equivalent, and 1/9 is a real number. Okay, so this is an element of the real numbers. Okay, therefore we can say that this is a monomial. So part B is a monomial, and the degree, once again, adding up 2 plus 2 plus 2, the degree is equal to 6. Okay, so for C we have 9a squared b squared. Now, remember with our rules of exponents, if I bring this up to the top, it's going to become unhappy, right? So that's 9a squared b squared is going to go to the negative 2. Negative 2 is not a whole number. It's a negative integer, okay? So this is not a monomial, so you don't have to find the degree, okay? This one is not a monomial. It's actually a binomial, which we'll learn about later, but it has two terms or two monomials. It consists of two monomials, and that is the broader term of a polynomial. Now we're going to broaden our perspective of monomials to polynomials, many terms put together. And to find the degree of a polynomial, you find the term with the highest degree. So we're going to do number 8 as an example. Classify each polynomial according to the number of terms it contains and give its degree. So the first one, once again, this is a monomial. Okay, so it is, we can say it's a monomial, which is a polynomial. And the degree of this is equal to 5. For part B, this is a term and this is a term. So this is one term and this is the second term. Now you look for, in each of these terms, you're looking for the variable that has the highest power. This is the only variable, right? And the highest degree or highest power of this is it's raised to the 4th. So wouldn't actually say that it's equal to that, but the degree of this is 4th. And because there are two terms, guess what that special name is? Two terms is equivalent to a binomial. Think of a bicycle. Okay? For C, how many terms do I have? 1, 2, 3. So 3 terms. That is what's known as a trinomial. We're going to be looking at trinomials just like this. This is also what's known in the future in Chapter 6. This is a quadratic. And if you recall, it makes a pretty parabola on the graph if you were to graph it. So that's just a little preview, but you don't have to write that down or think about that yet until Chapter 6. So that's Chapter 6 information. But it is a trinomial, and it is important to know that. It's also important to know that the degree of this is 2. It's a second degree. So another way you can say this is it's a second degree trinomial. Okay, and then the last one, this in fact is a monomial. So this is a monomial. And if you wanted to get technical, its degree, I think you just assume this is the zero. It's the zero polynomial, and the degree is not assigned. Okay. Part of your assignment asks you to write each polynomial in standard form. Standard form basically has two requirements. The variables in each term are written in alphabetical order, and the terms are arranged in descending powers of the first variable. So we're going to look at number 12, and this is a monomial. There's only one term here, believe it or not. It's just a bunch of things, a product of a bunch of different factors, right? So the only thing I need to rearrange is alphabetically, I need to put a to the fourth first, then b, then c to the third, and then the real number goes first. Okay, moving on. The next one here, negative 3x to the second, because that's the highest degree, minus 7x plus 8. Keep in mind, in this case, this is the leading term. Okay, and then on this one, looks like the highest degree is the third. So it's going to be negative 9x to the third, then 7x squared plus 13x minus 11. Okay, so remember the name of this section? It's adding and subtracting polynomials. And you're like thinking, we haven't even done that yet, but now we finally get to. So determine the sum or difference and write the result in standard form. So what we're going to do here is, in this case, this plus tells me that I do not need to change the signs on the parentheses, and I can actually drop the parentheses here because there's nothing else I need to distribute on the outside here. So it's just 8x minus 11. Now what I would say is you want to regroup and then get like terms together. And you guys have done this before, but we're just making it official. So I'm going to put the negative 5x plus 8x. I should put an equal sign. And I've got plus 3 minus 11. Now I'm just going to combine like terms. So negative 5x plus 8x is 3x. And then I do sometimes different symbols so that I know that those are alike. And 3 minus 11 is negative 8. So that is the answer for A. The only difference here now, see that we have a minus sign on the outside. So in order to remove the parentheses, remember it's that housekeeping thing. You got to clean up house. So we're getting rid of the parentheses. I'm going to change the sign. So this original term here was positive. Now it becomes a minus, and then this changes to a positive 11 or a plus 11. Okay, I'm going to regroup. So negative 5x minus 8x plus 3 plus 11. So you can do your symbols. Negative 5x minus 8x is negative 13x. And then 3 and 11 is plus 14. Okay, so now we're dealing with 1, 2, 3, 4, a polynomial with 4 terms, and we're subtracting another polynomial with 4 terms. Notice that in this first one, the highest degree is a to the fourth, and in this second one, the highest degree is also to the fourth. So what we're going to do is we're just first going to do some housekeeping. We're going to get rid of the parentheses. And because of the minus, I'm going to change the sign on every term on the inside. Now I'm going to regroup. So like terms, combine like terms. Okay, so it's negative 3n to the fourth minus n to the fourth. Whatever sign's out front is the sign that goes with it. So 7n cubed plus 2n cubed plus n, and then we have, oops, let's do, so yeah, we should do highest first. So I'm going to do the n squared first. Notice that there isn't an n squared in this one. And there's a plus n, and there's a minus 8 minus 4. Notice I went into standard form already. It's just a habit. I go from highest degree to the lowest degree. So in this, now I'm going to combine, so that's equal to negative 4n to the fourth plus 9n cubed. Oops, I'm going too fast, huh? Combining like terms, that's negative 4n cubed. Let's do 7n cubed plus 2n cubed. That's 9n cubed. Notice nothing to combine with n squared, so we leave it as is. We can do a simple though. Plus n, once again, n gets its own signal, or yeah, symbol, minus 12, because that is, what's a new symbol? Something new and different. So that's a negative 12. Okay, I went from the highest degree of 4 down to, this is a degree of 0, if you recall, because this could be thought of as n to the 0. Okay, now we're going to look at number 40, where you have to distribute. There's a number on the outside. So I'm going to distribute each of these. So that's 8x squared. 8 times 5 is 40x. And 8 times 2 is, and I have a minus there, it's 16. Once again, here, here, and here. And I'm going to change the sign on the inside because of this negative or minus. So it's minus 10x squared plus, because of that, 5 times 3 is 15x. And then it becomes plus 20. Combining like terms, we have 8x squared minus 10x squared, and then 40x plus 15x minus 16 plus 20. So regrouping, this gives me minus 2x squared, this is 55x, and this is 4. Okay, so number 52 is we have basically I'm subtracting a big polynomial from another polynomial, and then I'm adding a whole other one. So another way that you can arrange this, and let me show you, is I'm going to rearrange this from highest degree to smallest. So negative 11x cubed, and then it's minus x squared, so I'm just rearranging, plus 6x plus 7. The next one is I'm going to change the sign on each of these. Whoops, that one needs to go there. So, and I'm going to rearrange it and put it under the like term. So I have a minus 14 from that one. Then it becomes plus 2x squared. And then the next term is plus x cubed. So x cubed goes out front. You can put plus there. And then the last guy is minus 5x, but because of this negative, it becomes plus 5x. Now with this guy, it's just plus. So I'm just going to arrange under the like terms. So all the linear x terms go together, all the constants go together, so that's a minus 12. X cubes go together, so that's a minus x cubed, and 8x squared. The nice thing about doing this is we're used to adding this way. So if you go negative 11, there's a 1 in front of that. You can always put a 1 out. So it's negative 11 plus 1 is negative 10 minus 1 is negative 11 again. So negative 11x cubed. This is 10x squared minus x. So I'm working up. 8 and 2 is 10. Minus 1 is 9x squared. And this is 1420x. And 7 and negative 14 is negative 7. Negative 7 minus 12 is minus 19. So that's your answer for that. So that's another way to do it, is to line up according to like terms, so grouping like terms this way. Okay? So my last example is number 64. I also listed the assignment down here. You have it in your schedule that I handed out on Monday, but just so you have the numbers, this is due on Thursday. And don't forget that we have a quiz on Thursday as well. So please come to class. Okay, so to add perimeter, you just add up all the sides. So it's going to be, I'm going to start with this side down here. So I'm going to say 2x squared minus x plus 2. And then you know what I'm going to do? I'm going to do this, but I'm going to arrange it accordingly. And I'm going to put plus x plus 2. Then I'm going to arrange accordingly with this. I've got x squared minus x plus 3. And then my last side is x plus 3, so I have another x plus 3. And then we can line it up. We've got 2 plus 2 is 4, 7, 10. So that's positive 10. These cancel each other out. These cancel each other out. So there aren't any x's. 2x squared plus another x squared is 3x squared. So your polynomial, the perimeter, p, is equal to 3x squared plus 10. All right. I hope you guys enjoyed the lesson, and I'll see you on Thursday. Have a good day. Thanks. Bye.